Good morning, everyone. Let us introduce myself. My name is Sheikh John Saida. I am from Telangana. Today, I have done a topic about tools for an multiple CPU environment. There are 8 topics in this multiple CPU environment. First one is introduction. Next, grasping prototype construction environment. And next, experimental PPSC parallel constructing tools. Next, total prototype aids concurrency analysis, and next Memdizzer tool aids for train code design, and next Memdizzer tool aid for train code design as per automatic parallelizer for C. Let us talk introduction. The most cost-effective approach to gaining significant increases in computing power over the next decade appears to be through the use of multiple CPU environments. Such environments let us you break a problem into a concurrent process that will often run in a fraction of time required by a single CPU environment. Possible arrangements for such a multiple CPU environment cover a spectrum from parallel computing, where the environment has a single computer with multiple CPU, to distributed computing, where there are environments has several loosely connected single CPU machines. Unfortunately, to take full advantage of this capability, you must ensure that the code is optimally and partialized into process. Once you have done this, you must map the process into processor. If you do the partitioning of mapping poorly, you might actually get a net slowdown or incorrect behavior. These tasks are particularly important on distributed memory machines that is impose significant communication overhead when allocating processes and passing data to remote processor. To the best use of power multiple processor, we must make a jobs for process identification, process parsing, and process mapping easier for programmers to write a new program. Next, grasping prototype construction environment. GMD grasping prototype environment helps you incrementally construct, verify, and validate specifications for concurrent and distributed systems. Grasping includes the Seagrass formal specifications language and integrated support tool. Seagrass based on an integral of algebraic specifications and high-level prenates and offer a semi-graphical notations axiomatically specifies data behavior including control, concurrency, data distributions, synchronization, and communication using PrettyNet. The editor combines interactive graphs editing with incremental parsing and pretty printing capabilities. The prototyping tool supports symbolic interpretations through net animations and term rewriting. The graph editor syntax directly parsers and pretty printers are Seagrass specific AVD specifications of general components, including the grasping environmental kernel. You can also integrate non-general tools like type checkers, interface checkers, symbolic interpreters, and verification and analysis tools. Grasping integrates all tools through common interface and generic object base. It treats specifications and program internally as object rather than special syntax trees. Grasping integrates all tools through common interface and generic object base. It treats specifications and programs internally as object rather than special syntax trees. The structure of object is determined by ASDL declaration that are compiled into a set of manipulation parameters to construct objective and access modify their attributes. You can specify complex structured derived computations and object transformations in ASDL. Graspin supports static types checking for specifications, exploiting parametric and dependent type. The smallest unit to which the type checker can apply is whole specification module. It evaluates import-export relationship among modulus checkers, related context conditions, and then verifies the consistency between declaration and application of operations and type symbols. Next, we talk about experimental PPSC parallel construction tools. Oregon State University Experiment uh, mm, Parallel programming supports environment integrated tools, help you design and construct large software systems to run on parallel computers. The tools include a graphical design editor, a graphical target machine description system, a task mapper, scheduler, a parallel code generator, and performance analyzer. PPSC objective is to help PPSC objective is to help develop parallel software with little regards for the details of architecture of the target machine, language or parallel computing paradigm that can program it is to use. With the PPSC Parallax graphical design editor, you can use an hierarchical graphical description language called Extended Large Grain Data Flow to describe data and control dependence between tasks. You, you then use the target editor to provide a graphical description of architecture of machine on which the program is to run as well as some performance parameters that indicates processor speeds, communication delays, and bus rates. The task graph modules takes the output from the parallax and the target machine editor and using several generates Gantt chart description of the mapping of tasks on the processor and their scheduling. The figure at right shows the Gantt chart for one of the schedules produced by a task grapher for an image processing application. An execution performance analysis tool provides graphical description of the runtime performance of the software developed and feed the result back into scheduling tools. The current the current SuperGUI generates C-Linda code. Continuing research on this prototype environment include efforts to define a formal interface between the output from design tool and the PPSC tool, increased emphasis on data partitioning in tools, expanding the list of targets machines and expanding the list of target and languages, improving the large of the scheduler and the test derives of the system on several significant applications. Next one is Total Prototype Aid Concurrency Analysis. In this, the University of Illinois' total tool collections from the area development is being developed to support basic and applied research in automated support of the concurrency analysis for ADA tasking program. It analyzes its static and focus on program behavior affected by control and message flows. The current version handles entry, call, accept, and construct, but not a concept like expectations and overloading. Total formal underpinning it is use its Pitry as a model for concurrency and task interactions. Total has two major subsystems: the front-end translator and back-end transformation display. The front-end translator ADA or source code specified in task-oriented ADA language into PreNet format. The translator has three components tools: a tasking features like to produce ALT descriptions from ADA code, and entry call processor to extract entry call information used in the translation, and the PrettyNet customizer to produce the ADA PrettyNet. The resulting PrettyNet is in a textual format compatible with the Peanut PrettyNet software system. The backend information displays parser user queries about the input program potential tasking behavior. All through all through seeks to exploit PreNet's theory tools. User of the back-end toolkit needed have to knowledge of PrettyNets. To help users unfamiliar with PrettyNets makes queries, we have to develop the tasking query language for users and are developing a way to translate ADA-oriented TQL queries into PrettyNets-oriented queries. Total Although Total seeks to exploit PrettyNet's theory and tools, user of the backend toolkit needed to have knowledge of PrettyNet. To help users unfamiliar with PrettyNets, we have developed the tasking query language for users and developing a way of translate and DLQ oriented queries. Mimdesign tools at Fortran code redesign. Mimdesign help you find out how best to design an existing Fortran code from the static information derived from the Fortran program, dynamic information derived from the runtime static, and user-supplied information about the nature of program execution. The ultimate product of Mimdesign is an representative of programs' parallel structure, communication to topologies, and synchronization events. The process of transforming a serial program into a parallel structure involves collecting static and dynamic into database, identifying parallel structures from a global flow analysis. This information may either be generated into a program characteristics of or from statics gathered from an executive program of typical job. That a retrieval parallelizing tool for Fortran. Georgia Institute of Technology's PART is an interactive retrieval parallelization tool that analyzes Fortran 77 source code to generate a database of program information, include the program call graph, flow graph, and data dependence. PAT lets you browse the sub-program hierarchy and that select a sub-program from analysis and parallelization. The major difference between PAT and other interactive parallelization tools for Fortran like Parascope and FAST include: PAT performs incremented dependency analysis. You can insert delete lines of code and apply source code transformation without having to reanalyze the entire source program. PAT supports several dialects of Fortran includes IBM and Sequent Parallel Fortran and Cray microtasking and microtasking Fortran. You remove loop carried dependencies via a series of source code transformations include alignment and replicable, or you can protect loop carried dependencies via explicit serialization calls. The major difference pattern other interactive parallel tools are Fortran like Parascope and Fast include using an intelligent editor to redesign existing data structures for a parallel environment and to create parallel routines from existing program structure. Realizing the redesigned program and data structures, repeating the redesign and realizing until you're happy with the structures. Translating the redesign into parallel notation easily transformable into serial Fortran program. A Fortran program for shared memory (MMID) machines or Fortran program for disturbing memory (MMID) machines. Database generations and viewing, which includes program maintenance, parsing database generations, and global variable and constant tracking. As per automatic parallelizer for C. Parasoft as per automatic parallelizing tool addresses these issues for sequential C program. As per translate such C code into alternate C program by adding call to the expensive parallel runs time library. You can execute program containing embed calls to express on several parallel computers, including transporter system, N-tube and simult machines, workstations, networks, and shared memory architecture. In basic technique, uh, involved in aspect dependence on data flow analysis of program being parallelized. PAT provides allowable levels of users' interactive actions from automatic conversations to user selections of loops, code selections, parallelizing transformations, and deletion of fake dependence. PAT users Hurricane's menu-driven interface, including online help, has been designed for case of retargeting and rehosting. Using these stencils, Asper can develop a basically strategy using Express automated domain decomposition tools. And last, thank you.